This video is on Properties from Algebra, Chapter 2-2, pages 37 through 39. Properties of equality. The first property of equality that we're going to talk about is the addition property, which states if A is equal to B and C is equal to D, then A plus C is equal to B plus D. What that looks like in an example is if A is equal to 5 and C is equal to 6, then A plus C is equal to 5 plus 6. We also have the subtraction property, which states that if A is equal to B and C is equal to D, then A minus C is equal to B minus D. For example, this looks like A is equal to 5 and C is equal to 6, then A minus C is equal to 5 minus 6. We also have the multiplication property of equality, which states that if A is equal to B, then A times C is equal to B times C. What that looks like in one direction is if A is equal to 7, then A times C is equal to 7 times C. We also have the division property, which states that if A is equal to B and C is not equal to 0, then A divided by C is equal to B divided by C. For example, if A is equal to 8 and C is equal to 5, then A over C is equal to 8 over 5. Additionally, we have the substitution property, which states that if A is equal to B, then either A or B may be substituted for the other in any equation or inequality. So, for example, if I'm given that A is equal to 5 and I have A plus 7, then A can be replaced with 5 and we get 5 plus 7. It allows us to replace things. I also have the reflexive property, which states that A is equal to A. The example for this is that anything is equal to itself. It's like looking in a mirror. We also have the symmetric property that states if A is equal to B, then B is equal to A. This is telling us that order doesn't matter. If A is equal to 11 or 11 is equal to A, it's the same answer. I also have the transitive property. The transitive property states that if A is equal to B and B is equal to C, then A is equal to C. The example shows us that if A is equal to 9 and 9 is equal to C, then A is equal to C. The transitive property is an extended form of substitution. Oftentimes, substitution and the transitive property get confused for one another. The substitution property allows us to replace something. The transitive property allows us to make a chain and allows us to make connections. I also have properties of congruence, which deal with specific angles and segments. So first we have the reflexive property, which states that segment DE is congruent to segment DE. I also can say that angle D is congruent to angle D. For example, segments and angles are congruent to themselves, much like numbers are congruent to themselves. I also have the symmetric property that states if segment DE is congruent to segment FG, then segment FG is congruent to segment DE. And if angle D is congruent to angle E, then angle E is congruent to angle D. Again, with the symmetric property, order doesn't matter. It's the same on either side. I also can have the transitive property. It also states that if angle D is congruent to angle E, and angle E is congruent to angle F, then angle D is congruent to angle F. Again, when there is something in the middle that they share, it allows us to drop these out and just connect the first and last term. Other properties. Don't forget about the distributive property and any other properties that you learned in algebra, because we will be using these to create proofs. Again, proofs ask you to provide justification, and all of these properties are going to be giving us the justification for our proofs.